Today's video is going to be a summary of what I have in my blog post that I wrote a while ago. If you think this is very fast, I suggest you to visit my blog site, which is linked down in the description. So I think understanding FixedUpdate, the time step size, the maximum time step limit, and all those settings is very, very basic and really, really important to understand in order to make games. So these problems are very common, and I see many people writing in the forums and basically everywhere asking the same things. And when I go to my colleagues at work, or maybe I meet somebody and I have to talk about these things, you end up finding out that they don't really understand these concepts. And people that say, oh yes, I understand, yeah, FixedUpdate, you know, you place some code in there and it gets executed every time you set the time step to. That's not true. I mean, it's not true. And most of the people don't understand this. You have to spend a little bit of brain power to understand these concepts. So let's start. Okay, we are in Unity now, and the first thing we have to understand is the concept of the frame. You understand what a frame is, right? You have a game that plays at 60 FPS, that means frames per second. So you're running the frame 60 times in a second. Okay, well, this is very basic. If you go to the manual, I suggest you visit this website, the manual, but this page of the manual, which is under scripting concepts, order of execution for event functions. So here you have a list of stuff that happens in one frame, and you have the awake, on enable, reset. You have to know about this, and I always forget stuff that I need to look up here. So something very important that you have to understand first is that this part of the physics, which we're talking about in this video, starts with a FixedUpdate, then some internal executions, then the end of FixedUpdate, on trigger and on collision functions. So FixedUpdate, you know FixedUpdate, where it is. When you have a mono behavior, a component, the update function is executed once every frame, once. And generally, if you look at this graph, if you go to the end, you will see update in here. So it's inside the game logic part. And then at the end, you have all the rendering stuff. It runs after the physics step. I'm going to use Paint here, which is a very advanced software for drawing. So you have physics, then game logic, and then render. This is where all the stuff is drawn in the scene. The game logic contains the update, among other things. And this is run one time, and this one is one time every frame. The problem here, and something that not many people is aware of, is that the physics update is run from 0 times to n times. Why it's run 0 times, one frame, and the other one can be run 6 times? So let's talk about this. If we go to Unity and we hit play with an empty scene, in the game view you can check the stats here, and you can see that the speed at which we are playing this scene is around 2000 FPS, frames per second. So that cycle, the full cycle, physics or no physics, then the game logic and the rendering is run this number of times every second. The amount of time that a frame takes here is 0.4 milliseconds. It changes all the time. It's not always the same. If we go to the profiler, you can see that the frame is always taking different time. This means that the time it takes to execute each frame is variable. Why does it change? Well, there's so many things that change. Normally what you put in FixedUpdate is something that is related to physics in general. If it's something related to drawing or something that has to be seen in the rendering, then you put it under the update. So yeah, let's go back to the original question. Why is the physics step executed just one time, or maybe 0 times, or maybe n times, not just one time? You have to understand first the basic concept of game time versus wall clock time. Game time is the time passed inside the game world. It is different from the time passing for us, the humans, the human players, or people using the computer, which is called the wall clock time. This is our time, and this is the time inside the game. An app is said to be real time is when these two are similar. The game time and the wall clock time are similar. So 10 seconds that pass in the game are the same as our 10 seconds. What happens with slow motion? Slow motion means that maybe 1 second of game time will be maybe 10 seconds in wall clock time. That's slow motion, because very little time passes in the game. Also, when the game lags, for example, if there's been a while that the game runs very slow because of your computer is very old or whatever, and it runs maybe in 5 seconds in our world, that means that the time advanced very little compared to our time, the wall clock time. Okay, so have you ever used this inside an update? Time delta time returns the time passed from the previous frame. I will talk about this very soon. And when you get time in FixedUpdate, you need to gather time fixed delta time. So fixed delta time should be used only inside FixedUpdate, and delta time should be used only in update. Be careful with this. If you call fixed delta time inside update, it will return the delta time. Okay, so be careful with this. This is something very confusing, and there's a lot of people that's confused because they don't understand what fixed delta time is compared to delta time. So fixed delta time should be always used inside FixedUpdate or functions called from here. Also, if you're animating something, advancing some value, maybe adding some value to a value that you stored or something like this, you need always to apply the delta time. So if you're maybe something, you should use time delta time here. Sorry. You need to scale everything you do by time delta time. That way, if the time passed from the previous frame is smaller, then this something will be smaller and scaled by how much time it passed. This is probably one of the top 1 questions in the forums, which is my animation is not running smoothly. I add this value every frame, but things happen weird. Things are not smooth. This is the reason why. You should scale everything by delta time. But this is something, just a comment. Delta time is the time that passed from the previous frame. At what time? We are talking here about the wall clock time. So our time. How much time passed from the previous frame? This is useful to update the rendering. Update is always used for something that should be rendered at the end. But FixedUpdate should always contain stuff that you're calculating for the physics, or something that needs to be related to the physics or some simulation. Fixed delta time is gathered from here. If you go to Edit, Project Settings, in the Time tab, you will have FixedTimeStep, maybe you saw this before, and Maximum Allowed Time Step. So the FixedTimeStep is 0.02 by default. This is 20 milliseconds. So this is written in seconds. So 0.02 seconds is 20 milliseconds. The maximum allowed time step is the other value that we care about here, but we will talk about it later. So the fixed time step is what you get when you call time fixed delta time. This will return 0.02 in our case here with these settings. And it always returns the same value, always returns the same value. The fixed time step set in the settings should always be more than 0, of course. And then it has to be not very big, not very small. If it's very, very small, here is the simple rule. So by default it is 0.02, which is 20 milliseconds. If you make it smaller, physics will be more accurate. Not only the physics from native physics in Unity, physics, but whatever you calculate, if you're doing something related to physics, it will work better. Every plugin that uses or asset that uses FixedUpdate to calculate stuff that is related to physics will be more stable, and then it will be less efficient. Your simulation will be slower, and the whole efficiency of your game will be slower. On the other hand, if you make this value bigger, when I say bigger, I mean maybe 0.03, 0.045, the physics will get crazy. The bigger it is, less accurate, less stable, and then more efficient. It will be faster. It will execute faster. So you have to find a middle point in here, around here. So you can try values around, but you need to take care of these two variables, the accuracy and the efficiency. Let's talk about the basic concept, the most interesting concept of this, which is, well, let's understand what fixed time step means. That doesn't mean that the physics will take that amount of time to execute. So your physics update, your fixed update could take maybe one, let's talk in seconds, okay, because this is too much, but maybe 1 second, or maybe 10 seconds, or maybe 0.5 seconds. I know that's a lot, but it's an example. This is how much one fixed update takes. It can be variable. It depends on the complexity of your code, the complexity of the physics of that frame, the execution of all the fixed updates in all components in the scene, all enabled components in the scene. So as you can see, the length of the fixed update is not related to the fixed time step you're giving to it. So what is it? So the fixed time step is the amount of game time advanced in one fixed update, one call to fixed update or one physics update. Is the game time advanced but one step? This is very important to understand. Again, this is in my blog post. If you want to read it or maybe read more details about it, you can find it in my blog site. linked in the description. Okay, so first we're aiming for a real-time game. It means that the game time passed should be the same time passed for us, the wall clock time. So every time a frame passes, we need to catch up. The physics needs to catch up with how much time passed from the previous frame. So if we have frame 1, maybe it took 10 milliseconds, and the time passed. This is a wall clock time, right? The previous frame took 10 milliseconds to execute. Now in frame 2, the first thing we need to do is calculate the physics from the previous frame. Then we do the rest, and at the end we do the rendering. Just the same thing as frame 1. But the thing is, here under physics, we need to catch up with what happened in the previous frame, the previous 10 milliseconds. So we have to advance the physics 10 milliseconds. How do we do that? Well, we divide the previous time by the size of fixed time step we have in the setting. So if our setting is 0.04, so if our fixed time step is 0.004, which is 4 milliseconds, we need to divide the previous frame, which is 10 milliseconds, into chunks of 4 milliseconds. So we have 4, 4, and then 2. In the next physics update, we can execute or advance the physics twice. We can fill 2 gaps of 4 milliseconds, which is this one and this one. What happens with the third one? The third one, these 2 milliseconds gets accumulated for the next frame. So you only get the parts that fill one gap of fixed time step, so 4 plus 4, but the rest goes to the next frame. This means that we are executing fixed update twice, 2 physics steps. Hope you understand. So 4 milliseconds, you divide the whole previous time from the previous frame, divide it in chunks, and then advance the physics until we can't fill one of the chunks with 4 milliseconds. Now, how much does this frame 2 takes? Well, it takes the physics time and the rest of the time. Physics time will be twice fixed update. So if our fixed update, that frame takes maybe 1 millisecond, it will be 2 fixed update of 1 millisecond plus, I don't know, 1 millisecond. It doesn't really make sense here. But this frame took 3 milliseconds to execute, 2 fixed updates of 1 millisecond, and then the rest took 1 millisecond. So it is 3 milliseconds. So what do we do in the next frame? We start with the physics again. How many steps do we run in the physics step? Well, we still have to calculate the 2 milliseconds from the previous one, right? So we still have to calculate this 2 milliseconds from frame 1 plus the 3 milliseconds from frame 2. That's 5 milliseconds. So now we can run one fixed update, because we can only take 4 of those 5 milliseconds. 2 milliseconds and then 3 milliseconds, and we can only take this. But the rest, which is 1 millisecond, goes to the next frame. So 2 fixed updates, then frame 3 took 1 fixed update, and then what happens in the next frame? Since our fixed update takes 1 millisecond, in this case, it could change, but in frame 2 it took 2 fixed updates of 1 millisecond, but now we executed only 1, so we have 1 fixed update by 1 millisecond. And then we have maybe another millisecond to execute the rest. So this frame took 2 milliseconds plus the previous one that was accumulated. So right now we have 3 milliseconds. What happens now? We need 4, but we can't fill the chunk this time. So we can't run any physics update. So this is why some frames don't execute the fixed update at all. So there's no physics update this frame. So this is accumulated for the next frame, which is frame 5. So this frame has no physics update, and maybe it took 1 millisecond like the previous ones. So this 3 plus the 1 milliseconds here make 4 milliseconds. Now we can run 1 physics update and then the rest. This is why sometimes it's 0 fixed updates, maybe 1, maybe 5. This is why it is variable. I hope you understand with this small example. Now you can understand why, if you have a setting of 0.00001 seconds and in another project you have maybe 0.1, if you have to maybe calculate 1 milliseconds of wall clock time from the previous frame, you have to execute many fixed updates here because your chunks are very, very small. So you have to execute many of them to catch up. On the other hand, you have to execute less fixed updates for the same time. So if your fixed update takes X time, this will take longer than this to execute because every fixed update takes the same amount of time to execute. So the less fixed updates you execute, the faster it is. So this is the reason why you shouldn't set your fixed time step to a very, very small one. It makes physics better, but it is really slow. And if you make it very, very big, the time step, it will make things faster, but your physics will maybe not be that accurate or that stable. So maybe you're asking yourself, so if we're accumulating all the milliseconds left from the previous frame, then the physics are never accurate, are never on time. Exactly what happened in the previous frame is not displayed and rendered in the next frame. And this is true, it never happens. There are several methods, strategies or tricks that game engines and physics engines apply in order to hide this inaccuracy, but that is because it never executes the same amount of physics every frame. There's always a little lag between the physics and what should be happening at that frame and what is rendered in that frame. In fact, when a game runs in slow motion, you can see if there's no strategy or maybe method to make it, hide it. You can see objects popping from one position to the other. That is because the objects, especially in physics simulation, are not advanced because not enough time has passed in the game to be able to execute a next physics step. So this is why objects don't move until it accumulates enough time to run the next step. That is why objects pop. So physics engines and renderers, what they do is they smooth it out, or they add some interpolation between those positions so that you don't see the popping of the object. Let me show you here a little example of how this is implemented. So you have an accumulated value, and then what you do is at the start of each frame you accumulate delta time. Delta time, remember, is the wall clock time passed from the previous frame. So you accumulate it, and then while the value accumulated is bigger than the fixed delta time, you can execute a fixed update. But every time you execute this fixed update, you have to remove that chunk from the accumulated time. If the accumulated time is smaller than the fixed delta time set, as we saw in the example, then it will not execute fixed update. So this is how it works. The next frame, more delta time will be accumulated, and then you can start trying to run more fixed updates. What happens if maybe frame N took a long time due to very slow physics, something that was calculated and was very slow? Maybe your computer took too much time to execute, so maybe 100 milliseconds, I don't know. And the next step, to catch up, maybe you need to execute a lot of fixed updates. This is not a problem if your fixed update is very fast to calculate. What happens if your fixed update is really, really slow? Well, the problem with this is that it can get bigger and bigger. So maybe your fixed update took this amount of time and you need to execute 100 of them. In that case, your next frame will be slower than the previous one. So it will be maybe 100 milliseconds, then it will take 150, and then more, and that will kill your game, will crush it, will absolutely stop it. This is something called death spiral. The app or the game cannot catch up, and it never stops until the game stops. So to put a limit, what game engines do is add this parameter called the maximum allowed time step. If the previous time step took more than 0.33 seconds, then you can't take more than that time to execute. So you can get the chunks but not execute more than that, and then accumulate all the time for the next frame. So you probably think, well, maybe a lot of time is accumulated and it will get slower. Well, it will, but the game will never stop. Like, it will put a limit to that madness, to that crazy growing length of frame. What will happen is that if your frame is too big and you have maybe this is the max allowed, this part of the frame will not be simulated, so this one will, and then this one will be accumulated, plus whatever is the maximum. This will be, all this will be executed here. So what you see here is that the lag, or the difference from the physics and the rendering in those frames, are very, very different. So what's happening here is that the game will look slow motion. The physics are not advancing as fast as the game and the wall clock time. So the game will start to go very, very slow and then catch up again. When this problem is solved, then the game will run real time again. What happens if this time is always surpassed? This is always happening. Well, the game doesn't run right, doesn't run real time, or the game time will never run the same as the wall clock time, and the game will be slow. So that means that the application or the game is really slow, or your computer can't catch up. So that's a problem. What are the best values for fixed update and maximum allowed time step? First, you need to know the target platform. If you want to run at 60 FPS, 0.01666, so around 60 milliseconds. If you want your game to run at 90, for example for VR, then you have 0.0111. That's 11 milliseconds. So if the default setting is 0.02, which is 20 milliseconds, that means that we're giving it more time. What happens if the fixed time step is less than 20 milliseconds? If it's maybe less than these values, it is 10. That means that the fixed update will, if everything is fast enough, your fixed update should execute maybe 1, maybe 2 times most of the frames. If your fixed update is slow, then it will make all the application run slower, and that could bring problems with motion sickness, because the application of the game is not running smoothly. So try to make the value bigger than those values, more than 16 if you are under 60 FPS, and more than 11 if you're running 90 FPS. Then the second idea is that you have to set the fixed time step as big as you can. Bigger means less fixed updates and more efficiency, but remember that it can make your physics unstable. So be careful, test it, and don't make it too big. Another idea that I sometimes recommend is to set the maximum time step to a multiple of the fixed time step. So if you want to execute maybe 0 to 2 fixed updates, that means that if you have a value of 0.02 seconds in your fixed time step, then you need to set it to 0.04. This is the max. So this is telling the scheduler to execute only 2 fixed updates, because as you know, you cut in chunks, so you can cut 2 chunks of delta time, and then if that is not enough, then it will be moved to the next frame. So this will tell it to only use 2 fixed updates. If you want 0 to 3, then set it to 0.06, which is 0.02 by 3, right? This is something that works very nice. If you wanted to execute only 1 fixed update, for example, I worked on a project that the fixed update was really heavy, really slow to execute, so we couldn't let the physics to execute 2 fixed updates. So we set the maximum time step to 0.02, the same as the fixed time step. This makes only 1 fixed update. So always think about it, test it, see your profiling, and see how much it takes, how much the fixed update takes to execute. And the last advice I give you is to tell everybody about this, because not many people know this. So hopefully you understood this. I know it's a little hard to understand. I suggest you look at the blog post again that is linked in the description, And well, hope you found it interesting. See you in the next video.